Let R be the region bounded by the curve f of x equal quantity x plus 1 squared, the x-axis, and the lines x equals 0 and x equal 2. Find the volume of the solid of revolution obtained by revolving R around the x-axis. The first thing we're going to want to do is sketch R so we can visualize what this solid of revolution would look like and be able to figure out how to find the volume of it. So let's go ahead and sketch f of x equal x plus 1 quantity squared. That would just be a basic parabola shifted to the left one, so the vertex would be over here and it would come up something like this. And we are interested in the region from x equals 0 to x equal 2 and the x-axis and this curve. So here is our region R. Now let's visualize what that would look like if we rotated that around the x-axis. We could see it would look something kind of like a megaphone. Would end up like this, something roughly like that. Here we've got the axis through the middle. So what about a representative slice here? It's a little representative slice with thickness dx. If we visualize it here, we can see that it would be a disk, and a disk of radius r, r being the function value, because this is simply the y value or the function value there. So when you figure these out, you want to visualize, not memorize. So you don't want to try and memorize some formula for the disk method. You want to draw a picture and say, okay, what I'm going to do is find the area of this circle here, multiply it by a little thickness dx, and sum all of those up, in this case from 0 to 2. So we've got the integral of 0 to 2. The area of a disk is going to be pi r squared, but our r was x plus 1 quantity squared, so then that will need to be squared, multiplied by our little thickness of our disk, which is dx. So this volume of the solid of revolution will be the value of this definite integral. Now we could move the pi out in front, and we've got 0 to 2, and this is just going to be x plus 1 to the 4th dx. So as we go to evaluate this integral, let's let the stuff inside the parentheses here be u. So if u is x plus 1, then du is just going to be dx. So we could express this as pi times the integral. Now we're going to need to change our limits of integration because we're going to express this in terms of u. So let's go ahead and substitute in 0 up here where we had defined u in terms of x. If we put 0 in for x, we get u equal 1, so our lower limit becomes 1. And then when we put a 2 in for x up here, 2 plus 1 is 3, so our upper limit is 3. Now let's go ahead and evaluate this. Well, this would be 1 higher power, but we'd need to multiply by the reciprocal of that power, and then this would need to be evaluated from 1 to 3. So that's going to be pi over 5, and if we substitute in the upper limit, that would be 3 to the 5th minus, substituting the lower, 1 to the 5th. And we can see our volume of our solid of revolution then would be 3 to the 5th, which is 243, minus 1, which is 242, multiplied by pi over 5. So 242 pi fifths is the volume of our solid of revolution.